Introduce our second keynote speaker. I'm pleased to introduce Hugh Henderson. Hugh is General Manager at CDH Energy in Cazenovia, New York. CDH is a charter member of the COE, and Hugh and CDH have been involved with us in a large number of projects, going right back to Jensen's first lab with a project on unplanned airflows and projects in the field. Hugh will be giving presentations in tomorrow's track on some of this work. So he works extensively with NYSERDA on various energy efficiency delivery programs, as well as conducting research and demonstration evaluations. He worked formerly for the Fleming Group, for the Florida Solar Energy Center, and for Carrier here in Syracuse before starting CDH. Without further ado, Hugh Henderson.
Thanks, Ed. So it's my pleasure to introduce introduce Joe Lstiburek. I've known Joe for about 15 years in various we worked on various things together. He has a PhD from the University of Toronto. So he's Canadian by birth, but he's entertaining by nature. I think you'll see what I mean in a minute. And he's done all kinds of groundbreaking work on building envelope and ventilation. And he's done this so long that he got to name his company Building Science Corporation. So he got the term. And he works on various things at ASHRAE. He's a longtime participant in the Building America program, so he does a lot of residential energy efficiency. So Joe is about energy efficiency, but more importantly, he's about getting it right so that the building stays there for 50 years. Because the first thing about sustainability is making the building durable so it'll last. And the Wall Street Journal, and I love this, Joe, but the Wall Street Journal said he's the Dean of North American Building Science, and I agree with that, so please join me in welcoming Joe.
Well, it's a real honor to follow such a distinguished speaker. It's good to see you again and see old friends. Thank you very much for inviting me. It's nice to not have to fly someplace to go. It's nice to be able to have a nice leisurely drive. Many of my friends, longtime friends, are from this neck of the woods, so it feels very much like home to me as opposed to coming into some strange place. So once again, thank you for inviting me. Let's see if you have a real computer. It's called a Macintosh. All right, damage functions. Let's assume that we've done the basic things correctly. The building doesn't blow away, the building doesn't fall down, and the building doesn't burn. Structural engineering is a very mature profession. Nothing much happens in structural engineering anymore, which is why structural engineers are so boring. They're the folks that didn't have the personalities to become accountants. Bridges used to fall down. That's when they had personalities. Buildings used to fall down. 100 years ago, they were exciting. Today, to make a structural engineer's day, take him or her to lunch and ask them about moments. Their eyes will light up. Nobody ever talks to me because nothing ever happens. The people that have personalities are mechanical engineers because nothing works. And all we do is blame the architect. Those sons of bitches, if they gave us an enclosure, we could get a condition. I can't believe this. And so architects and mechanical engineers have personalities because things don't work. Well, why? Well, the priorities were correct. You deal with stuff that kills people before you deal with stuff that irritates them. And you deal with stuff that kills people quickly before you deal with stuff that kills them over the long term. Everybody with me on this? And so we're doing pretty good at not killing people quickly. And we're doing pretty good at, the fire in the structure. Buildings don't blow away during hurricanes. We build in North America out of stuff that burns, but people don't die from fire. This is quite remarkable. Woo-hoo! All right. So what's left? Well, I view these things as damage functions, and here are the three big ones: water, heat, and ultraviolet light. And of the three, water is the ugliest. It's the worst. But it's kind of hard to get excited. That person died because the building fell on them. I got wet. It's not the same. So we're now dealing with the wet and the heat and the UV, and it's important that when we deal with those, we don't screw up the fire in the structure. We're so good at the fire in the structure that we sometimes forget how bad it was at one point. And it was horrible at one point. Now, not an issue. But let's not forget about that. We shouldn't be wrapping our buildings with napalm, for example, unless we figure out a way to, not ignite it, for example. So I was asked by Hugh to say, well, what do we need to know? Well, it's not very complicated. After they don't fall down, they don't burn, you need a water control layer, whose function is to, amazingly enough, control water. And controlling the water is way more important than controlling the air. We need an air control layer, but we need a water control layer before we need an air control layer. I don't get a call at 3 in the morning saying, my building is leaking air, my building is leaking air. But I will get a call at 3 in the morning saying, I can't believe you screwed this up, it's leaking rainwater or groundwater. We need a vapor control layer. But in the grand scheme of things, compared to an air control layer, it's trivial. It's a waste of time. Now, the only reason we have vapor control layers or vapor barriers in buildings is because it's the only thing we could calculate. If the only thing you can calculate can be calculated, we obsess over it, right? The only tool you have is a hammer, everything is a freaking nail. Vapor diffusion calculations are a colossal waste of time. In fact, the biggest problem is not the lack of vapor barriers, it's a vapor barrier in the wrong darn place. And at the end, we have a thermal control layer. That's insignificant compared to the water control layer, the air control layer, and the vapor control layer. And if it's insignificant, the building code obsesses over it. You value this, R value that. We've got pages and pages of this. On the water control side, the codes basically say, be good and good luck. And that's outrageous, but that's what we got to deal with. So what would the perfect wall, clean sheet of paper look like? Here it is. This is pretty simple. The structure is on the inside, and you put your water control layer on the outside of the structure. I know. You can't believe the arguments we have over that. I mean, how could anybody argue that you want a water control layer on the inside of your structure? But we have those arguments. It's a good thing they're all in ashtrays so they can waste their time screwing things up there as opposed to going up and screwing up real buildings. It just flabbergasts me that this argument takes place. So I'm here to say, stop it. Put your water control layer on the outside of your building. We also need an air control layer. Well, where's the best place for it? Gee, on the outside of the building. Where would you want to have your vapor control layer? On the outside of your building. Where should the thermal control layer be? On the outside of all of that. And the outside of that is your cladding system. And the cladding system should have an air gap behind it and be drained. That's it. This is all you need to know. That's it. This works everywhere, all climates. Works in Montreal, works in Miami, works in Minneapolis, Memphis. You don't need a calculation. It just works everywhere. I teach grad school now, which is kind of a trip considering my background. Back in the day, 30 years ago when I was in grad school, we used to fail stupid people. We're not allowed to do that anymore. Apparently it's discriminatory. And so I can't fail them. And so I say, you're an idiot. There's no hope for you. But we're going to reach this bargain. For as long as you live the rest of your career, as long as you specify this wall, we're good. Because it will work everywhere. Now, make sure it doesn't fall down and blow away, and we're good. Pretty neat, huh? Well, okay, if that's the perfect wall, what does the perfect roof look like? Well, you flip it one way, you get the perfect roof. Flip it the other way, you get the perfect slab. This is what we call an aha moment. The laws of physics are the same for the walls and the roof and the foundation. I mean, who knew? Old people wrote it in books that are found in libraries, not on the internet. The books are so old, you have to ask a librarian to get them. That involves a social interaction, which is why young engineers never learn about this stuff. Now, perfect roof. There it is. You replace the ballast with dirt, grass, and a goat, and you get a green roof. Huh? Pretty neat. We didn't call them green roofs before there were green roofs. We called them protected membrane roofs because the membrane was protected from ultraviolet light, water, and heat. You know, if you put the membrane on the top, yeah, you can get at it to replace it, but you have to replace it because it's exposed to the damage functions, right? Nodding here would give me a sense that I'm connecting with you, that, you know, okay, you got it. You flip it, you get the perfect slab. Dirt, stones, insulation, control layer, concrete. Pretty neat, huh? Everybody with me on this? All right. So, let's take the perfect section. Put in the perfect wall, the perfect roof, the perfect slab. What do we got to do? Now comes another aha moment. We got to connect them. There you go. See, this obviously a graduate of a famous university. So we got to connect them. But how we connect them is the magic to building enclosure performance. We connect the water control of the roof to the water control of the wall to the water control of the foundation. The air control of the roof to the air control of the wall to the air control of the foundation. The vapor to the vapor to the vapor, the thermal to the thermal to the thermal. The continuity of the control layers is it. It's the whole darn thing. When I teach the youngsters in our firm or at the university, I say just take a colored pen and trace around the drawing set the water control layer. And anytime the pen leaves the paper, you've identified a discontinuity that needs to be addressed. Well, it can't be that easy. Well, actually, it can. That's that's the deal. And you do this for a living? Well, actually, yeah. It's remarkable that as simple as this concept is, it doesn't happen. It's flabbergasting to me that I can earn a living saying roof, wall, foundation, connect them. And to deal with the architects, I tell them to use different colored pens. I thought that was going to get a big laugh, Hugh, and this is one of the most difficult audiences. Okay, well, the problem is we put freaking holes in the building, and they're called windows. Now, windows are a problem because they have to do everything a wall has to do and more. They have to handle water, air, vapor, and heat. And people actually want to be able to see through them, so you have to handle basically radiation, right? You want the visible light to go through, and you want to hold off the infrared and the UV, right? You want to be spectrally selective. And not only that, every now and then some lunatic expects to be able to do what with them? Open them. No wonder they cost more than any other component in the building. But you know what? We have phenomenal windows in North America, particularly in the United States. We have the best windows in the history of windows on the planet, right here. Unbelievable. But we have more window problems than we've ever had. It's not the window, it's not the wall. It's the connection between the window and the wall. In fact, it's so bad, people say there are only two kinds of windows in the world, windows that leak and windows that will leak. So what do we know about windows? They leak. It's not the windows that are leaking, it's the connection between the window and the wall that's leaking. And it's fundamentally simple. You connect the water control of the window to the water control of the wall, the air control of the window to the air control of the wall, the vapor to the vapor, the thermal to the thermal. There are specialized companies and consultants that do nothing but this. Isn't it amazing? I mean, I have more responsibility. I do the whole enclosure. There are people that just do the window to wall. I mean, how bizarre is that? You know, not even the window companies who make them get it right. Wouldn't it be neat if they would ship windows that were labeled? I said, you know, this is our water control piece connected to yours. I'm waiting for that. It doesn't happen. You call them up, well, we'll get back to you on that. They don't even know. It's remarkable. Then you look at a set of architectural drawings. Everything it says, by others. You know, installation by others. Shop drawings by others. Don't let this son of a bitch on your job site. By others is a problem. It's amazing. We shouldn't have these problems, and yet we do. What can I say? So, what does one version of the perfect wall look like? Well, here it is. This is the institutional wall, sometimes called the 500-year wall, for 3 reasons. It represents 500 years of evolution. It will last 500 years, and it'll take your clients 500 years to pay for it. All right. So what do we got? We got rocks piled up because why? Rocks don't burn. Repeat after me. Rocks don't burn. On the inside we have sheet rock. Why? Rocks don't burn. On the outside we have rocks. Why? Rocks don't burn. And we could make the insulation fluffy rocks because why? Rocks don't burn. I mean, does anybody not get this? But you know what? You could put stuff between the rocks on the outside and the rocks on the inside that burns because the stuff on the outside doesn't burn and the stuff doesn't on the inside burn, so you've got the stuff that burns between stuff that doesn't burn. If I'm getting too complicated, stop me on this. It's not complicated. This is it. This is the best of the best of the best of the best that we know how to do. Can't do better than this. Works everywhere on the planet. Everywhere. Even in Syracuse. We can't afford it. So we get rid of the rocks and we build with steel studs. And we have sheet rock on the outside of the steel studs and sheet rock on the inside of the steel studs. And everything else stays the same, right? Huh? Yeah? Yeah. Whoa. Notice that there's no insulation in the steel studs. Because insulating a steel stud is a thermodynamic obscenity. You take an R20 bat and put it in a 6-inch steel stud cavity, the effective thermal resistance is R4. You lose 85% of the thermal resistance because of the conductivity of the steel. Steel is 400 times more conductive than wood. You know how I know this? I've never seen wood wiring. I've never seen a wood frying pan. Well, once. Now, it was a NYSERDA project. So, what have we learned to do with steel framing? We have to insulate it on the outside. That's the only way. I learned this at a very early age, growing up in Canada as a child, as do all Canadian children. We learn when it's cold to pull the sweater over the outside of us. We don't eat it and shove it into our ribs. So we must be sweater wearers, not sweater eaters. Now, with wood framing, you could eat your sweater because the wood is not conductive, but you're still better off wearing the sweater than eating the sweater. Now, this is kind of neat if you build in places where you ought to be building. like not on a beach in New York, like not below grade in New Orleans, like maybe not on a sandbar in the middle of the Gulf of Mexico, like the entire state of Florida. That would be stupid. Why would people do something that stupid? Well, that's just the way it is. And so clearly we as engineers and architects have to help stupid people build in stupid places in a non-stupid way. Because telling them, that's stupid, you shouldn't build there, and it's certainly not out of stuff that is going to get wet and can't stay wet, that would be simple. Don't build there, it's dumb. Well, you know, it's my right to be stupid. Well, yeah, it is, but it's not your right to have me pay for your stupidity. But that's an argument that I apparently have lost. And so we're going to have stupid people doing stupid stuff on the water, and my job is to figure out what's the least stupid way to do that. And so here we go. I just needed you to know where I'm coming from. The best way is don't build on the beach. Don't build in the swamp. Don't build below sea level. Don't do this. But that argument apparently is too complicated for people to understand. So here we go. What do we know here? Where is this? This is New Orleans. We built below sea level. How far below? Well, in this particular case, what's the ruler? It was kind of neat. The Army Corps of Engineers was asked to do a study. It took them 2 years to figure out what the flood limit was. I said, why don't you just go and measure where the stain is? I'm an engineer, I'm not a scientist. Apparently I don't understand that if we had a wonderful experiment. If the whole place floods, what got wet, got wet. And you should maybe build above that. Yeah, I know, it's how irresponsible of me. So, turns out that people who had built in the old days in New Orleans had figured that out. And a lot of the old houses were built where? On higher ground and were built high. Okay, I have to show you this. This is stain house. I just drive around New Orleans and look at the old stuff. What are you, stupid? Look. Well, there's a window there. There's nothing in there. It's empty. It's rocks. Nothing. Rocks can get wet. They dry. Paper face gypsum. Nah, bad idea. Paper, water, bad. Well, we better do a study. No, it's just obvious. It's bad. Look at this stuff. So lesson number 1 is build up. How far up? Look around the neighborhood. The older buildings will tell you. You need to be a building whisperer. Listen to the... That got a big laugh last night at an ASHRAE meeting in Boston. All right, this is how you build in wet areas in the Carolinas. Elevated slabs. In this case, they're 3 feet up. They're slab on grade. Why? Because there's no wood in the foundation to get wet because it's rocks and it's built up high. The entire framing has got no wood in it. It's cement and cellular PVC. And so if it really gets wet, all you do is take a power washer and hose it down. This was done by Canadians. That's why we're called hosers. All of this is more or less water indestructible. The key was to not have it burnable, right? You don't want stuff out of plastic that burns, right? You want stuff that is waterproof but not a fire hazard. Everybody with me on this? Okay, I think you got it. Well, this is a little higher. Well, why? This is on the Outer Banks of North Carolina. That's what I call a crawl space. What do you put in there? The boat, your car. Well, it's crazy. Well, no, it's not, because if you don't do that, you're going to have to rebuild again. And my argument is the next time you do it, you should use your money, not mine. I'm tired of this. Well, that's crazy. Well, actually, no, it's not crazy. The better choice was, don't even be there. You could be a mile away. This could be like a park. You could have joggers and sunbathers, and you can grow organic vegetables or whatever is cool this month. Right? No, I need to build there. Okay, you're going to have to build up. Well, you got to keep the wind from blowing it off. But that's not anywhere near the problem. If a wave hits this, being hit with a wave is much more difficult to design for than being hit by wind. 150 mile an hour wind? That's trivial, Bubba. Yeah, that's easy. A wave? Whoa. This will take a wave. The structural engineers are good. Remember, they're boring and they're very good. Says, oh, you're going to build an island in the Gulf of Mexico. Well, there it is. The better choice was not building there, right? Keep reminding you that. Where should we put the stuff that we don't care about, like our cars and our boats and our snowmobiles? I don't think there'll be a snowmobile here in Pensacola, but you get the idea. We don't put the emergency generator in the basement like we do in New York City. You should maybe put it up higher. You should maybe put your furnace and your water heater in your attic, not in your basement. Huh? Yeah, I know that. What a colossally stupid concept, right? Because we want to put our wiring and our heating and our cooling system where it'll get trashed. So we have to throw it away. So, what's so magic about this? It dries in and it dries out. It's the perfect wall. It goes both ways. Awesome. It dries out in the winter, dries in the summer. Second law of thermodynamics, right? Okay, warm to cold. Why? Because. You don't believe me? Look at the psychopathic chart. Trouble is that this is very expensive to build. Can we get reasonably close to this at a small portion of the cost? All right, so this is the best of the best of the best of the best. Can I get 80% of the way there for 30% of the money? Well, yeah. You can take your rocks and put stucco on the outside, and you can put your insulation on the inside and make it non-water sensitive. And guess what? This is the most common way of building in Florida, south of Interstate 4. Why? They get lots of hurricanes, and things get wet. And even in Florida, they've run out of money, right? Insurance people are saying, well, I don't want to insure you because you're in Florida. That's like stupid. Why would we want to insure people? So the whole point of insurance is to pay you to give them money so that they don't have to give it back to you, right? You know how that works, right? And if they have to give it back to you, they don't want to give it back to you, so they're not going to insure you, right? Those of you that are statistically challenged don't understand this. Those of you who have taken statistics understand what I'm talking about, right? So we've quietly, over 25 years, figured out how to build hurricane-resistant walls that don't take much to fix when everything goes bad. That's a block wall with stucco on it. And where do we run the wiring? Up high. Why? Down low, it gets wet. And we don't put fluffy stuff in the walls because fluffy stuff smells when it's wet, right? The only thing that we haven't quite yet learned is we still use paper-faced gypsum board, but the good news is it's cheap. You have a hurricane or a flood, you just rip out the gypsum board and the carpet, and you're only doing it at the lower part, and you move on. We have the technology to not even have to do that, I'll show you. But this is pretty neat. They don't blow away in Florida, and we don't have to trash them anymore. It doesn't take much to fix them. Why? Because they keep getting hit, and we're getting real smart at how to deal with it. It's kind of neat. Well, maybe we should take the lessons of a place that always gets whacked and apply it to places that don't get whacked as much, but might get whacked more than they have in the past because maybe things are changing. What are the odds? So here's the classic Florida wall. It just needs only one improvement, which is what? Build it higher, right? Nodding here would, yeah, all right. And so we're learning to do what? Build it higher. Wow. You know, this is pretty, rocks don't burn. There's no fluffy rocks in there. Things can get wet. Guess where they put the air conditioning systems? In the attics. The problem was is that we put them in the attics, and the attics were outside. Now we're putting the attics inside, and so now the stuff is inside, even though it's upstairs. You think about that for a minute. This is pretty neat. We build everything that way. The really south part of Florida, everything is rocks. All floors. Between the south part and the middle part, the first floor is rocks and the second floor is wood. We've built the wood in such a way that it doesn't blow away. It's kind of neat. You see, the riskiest part of the building gets the toughest stuff. Huh? Yeah, I know. And that's the insulation of choice. Because if it gets wet, you take the gypsum board off and you just power wash it and you'll be done. End of story. You don't have to redo the outside. Well, you might want to repaint. You want to probably power wash, get the mud stains off, right? Not in here, you get it, okay? This is easy. This is why it's going to be, this is why you're going to find insurance companies coming back to Florida, because they're not going to have to pay anything when something happens because things are built well. See, you know when you get a good insurance rate, you've got a good building because it's built well and they're not going to have to give you money because you're not stupid. Okay, well, can we even do better? Well, yeah, we can use spray foams. Why are spray foams better than the sheet goods? Well, the sheet goods require skill and workmanship. The spray foams, you just point and spray. Problems with the point and the spray is that you want to make sure that the stuff in the stuff stays in the stuff. You should have listened to the first speaker. We want, non-VOCs. We don't want emissions. We don't want stuff burning and emitting bad stuff. The good news is we actually know how to do this. The bad news is we're not doing it because we haven't yelled at enough people to make them do it. So I'm always yelling at them. Well, embarrassing them. It's like lights and cockroaches. You shine the light on them and the cockroaches will scurry around and then, oh, okay, we can do that. Well, why aren't you doing it? Well, because you didn't shine the light on us. So it's time to shine the light on them. It's even better to do this with steel studs because it's easy to wash a steel stud. If you have a wedding event, like a flood, and you don't get around to cleaning it up for 6 months because you're arguing about whose fault it was, wood is good. If you fix it right away, oh, wood is bad. Well, no, this is going to work. Wood is remarkable. First of all, it grows on trees. And this might shock some of you, but we used to build things called boats out of them and sail them around the entire freaking world. And they were just fine because we looked after them. You can build houses out of wood and they can get wet as long as you dry them. Huh? Yeah, I know. I'm such a smart guy. What's neat about Florida is we kind of predict where the hurricane comes from, and we can say, run! Get the hell out of Naples! Right? Well, what if you're on an island like Guam and a cyclone is coming? Where are you going to run? Well, it's a long way to Japan, and the boats are all gone. Why? Because there's a cyclone coming. So you gotta hunker down. So this is actually military housing on the island of Guam. That's where the Marines are hanging out now because the Japanese hate us again. And so you can't run. You're gonna have to hunker down. So these are concrete houses, concrete roof, concrete walls, concrete slabs. They're designed for 300 miles an hour. They're not gonna go anywhere. The problem is that they're going to get wet. They're going to get really wet. And so we want to line them on the inside, not on the outside. Well, because we line them on the outside, the stuff is going to get damaged and blow off, and so we put it on the inside because the stuff isn't going to get that damaged and blow off with impact. But if it's now on the inside and it gets wet, we have to make sure that it dries before it gets trashed, and so we have to choose stuff in such a way that we can either rip it out and throw it away, or that it's easy to clean and dry. Everybody with me on this? And so we build them out of concrete. We can power wash them on the outside. On the inside, we don't use paper materials. We don't use fibrous insulations. We actually have things removable so that we can just power wash them with soap and water and bleach afterwards, and then plug in a dryer. Because they're going to be wet for maybe a month, because if you're going to get hit that hard, your power is going to go out, right? No air conditioning, no dehumidification. All right. That's kind of neat. And you don't want them to get wet persistently from underneath, because the island is wet because it's in the middle of the Pacific. Well, not in the middle, it's off to one side, you know what I mean. The guy said, no, it's not in the middle. You're right, it's over there. And then you elevate everything. I love this. If I was in charge of Florida, which I'm not, this is how we would build every house in Florida. An elevated slab on grade, first floor out of rocks, second floor out of wood, nothing vented on the second floor, and nothing that can't be easily cleaned without throwing it away. Oh, this is the way we're building now. Is that amazing? Why? Winston Churchill. Americans can always be counted upon to do the right thing after all of the alternatives have been exhausted. We are now building phenomenal houses in Florida to resist hurricanes. And they're also energy efficient. They're very comfortable. We still have issues with the stuff in the air. We got to handle that too. But you know what? This is pretty neat. So Hugh says, well, how should we build in New York from the Sandy perspective? Take the Orlando house, and if you're stupid enough to put it on a beach, put that on the beach in New York and New Jersey. You're going to not have the tile because the tile looks kind of weird in New Jersey. So you're going to have, asphalt shingles that'll blow away. That's okay. Shingles are cheap. A couple of shingles blow away. Whoop-de-doo. You don't want the roof to blow away. That's okay. We got that figured. Structural engineers are good at this. They're really good at it. Remember? So there you go. Ultra efficient. Rocks don't burn. Build up. Can take the flood. Put the important stuff up above. Call it a day. The only better way of doing it is don't build there. Okay, can we even do better than that? Well, don't insulate in the wall cavity at all. If there's nothing in the wall cavity, if there's nothing to get wet, you can just hose it down, right? Pretty neat. What if I don't have all of the money in the world? What if I can't build slabs? I can put them up high on piles, piers. And again, the key is no fluffy stuff in the cavities. And you can open it up and dry it, because you're going to have air change, but you're not going to have what? Air conditioning and dehumidification, because you're not going to have power. Huh? Pretty awesome. As a matter of fact, we're building on the Redneck Riviera this way. That would be Destin, Pensacola. Redneck. Don't you ever watch those movies where they're, you know, Frankie Avalon and, oh, that was Mal, oh, never mind. It's pretty neat. I can use natural drying if I don't have the power. External insulation. Wear the sweater. Don't eat the sweater. You can take a hit and you're not trashed and you're efficient. There's a million ways of doing this. I don't like slabs. You can't insulate them. Well, sure you can. Insulate them on the top. Absolutely. Don't have to worry about termites, insects. Structural engineers love you because they can do post-tensioning. Not a big deal. I don't want to hear from you, oh, we can't do that here. Can't do that in New York. It just doesn't work for us. Well, sure it does. Just different. You all need to travel more. You should probably get on a plane. Apparently this week you have to wear a mask and a hazmat suit, but flights are cheap now because nobody's flying today. Did you hear that? They got, you know, like, oh my God. Anyway, so you should go visit other parts of the United States, particularly where bad stuff has happened a decade or two ago, and look at what they've done. And then kind of figure out, wow, how are they figuring things out? Last concept, because I'm out of time. We have a real problem with wildfires, not here, but almost everywhere else. And they don't like venting roofs, which is a real problem, because if you don't vent your roof will rot. But if you vent your roof will burn. So it's a race between whether it's going to burn or whether it's going to rot. And by not venting it, I guess they feel that the roof will get so wet it won't burn. I think that's maybe the logic. And so what we've learned to do is abuse graduate students to get them to build a test roof that is venting vapor by diffusion, not by air. And why is that important? Well, almost 30% of the damage that occurs now in Florida hurricanes is from water entering roof vents, because the roof vents leak. But if the roof vents are waterproof but vapor open, they don't leak. You with me on this? Now, if you make this also fireproof, you could vent your roof in Colorado and California and not have to worry about the burning embers or the rainwater entry. I'm just saying, we have the ability today to build stuff that doesn't blow away, that doesn't burn, that doesn't get too wet. If it gets wet, we can have it dry without having to use mechanical drying to make it work, be energy efficient, and maybe even have good air. It just means you need to bring all of the best to New York and pick and choose. That's what's so irritating about New York City, isn't it? The best in the world ends up coming to New York City. What we want is the best in the world for technology come to New York State and pick and choose when you rebuild after the next disaster, because you know there's going to be another one. Do it the smart way. Thank you very much.
A couple of minutes for questions. Let's get a mic over here to,
I'll just talk loud.
right behind you.
When you're dealing with floods that bring sewage, how do you deal with cavities that you can't get to and clean out? Or do you just construct differently?
No. You have to power wash with water, with clean water and bleach to deal with that. So you have to take the lining off. It's the sewage water, the brown water, the black water that is the biggest problem. So it's going to get wet, it's going to dry. You have to clean it, and you're going to have to clean it traditionally. And so you have to take the lining off to get at those surfaces.
But I'm thinking of, for example, the cells of concrete blocks. Is that a problem?
No, it's not. That's not a problem. Why? Well, because we're lining them with stucco on the outside. You're not going to get that gooey stuff on the inside. It was not been a problem in Florida or in the flood areas, but it is a problem with gypsum board. It's a problem with wood. It's a problem with steel studs and particle board. We have to hose that down with bleach and water, or whatever the magic GUI is, but the blocks haven't been a problem. Now, even better, concrete, right? Even better.
So how do we overcome the momentum that we have in our building approaches and what people are used to?
Well, telling everybody, talking about it. Elections have consequences. This is America. Change it. I did my part. I'm not even a citizen, I just pay taxes. I'm the perfect guy. Taxation without representation. That's why I'm in Boston.
But it just seems that there's so few that really understand the technologies and what's already available. As you said, it's already available. It's not something that has to be developed or understood.
All right, well, so here's an easy start. If I was an insurance company, I wouldn't insure you. And if I can't insure you, I can't finance you. So where's the money coming from? People are protecting their money. And I'm seeing this trend in office buildings and condos and apartments now. Every apartment building and condominium that goes up has to have an enclosure review by a third party, or Morgan Stanley or Citibank doesn't finance them. So now we have this entire new profession started up called, building commissioning. ASHRAE's taking a huge lead in that. Well, why did it happen? Well, because they can't get the money unless it happens. And why are they not getting the money? Because they don't want to lose the money. They want to protect the investment. So if I was going to, you wouldn't get any money from me to rebuild on a beach if you didn't do it correctly. That's how I would do it. And the financing people are figuring this out on their own. Why do you think the insurance industry left Florida? Well, now they're coming back. Why? Because the buildings are better. Amazing. In some parts of the state, you can't get homeowners insurance here because of ice damming. You can't get it if you have ductwork in your attic and you have a hip roof. Right? Your rates are a lot higher. Nodding here. You know about ice damming? It happens where you have lots of snow. Oh, where are we? In the part of the state. You leave. See, people in Syracuse go to Buffalo to get away from snow. Right? So now you're getting information from the insurance side saying, well, we're tired of paying for ice dam damage. We're going to charge a higher premium for a crappily built roof. We're going to incentivize you if you build a better roof. Right? Duh. It all ends up about the money, doesn't it? Yeah.